Okay, I'm going to quickly attempt to do lessons 44 and 45. I'm breaking it up since I had that disaster of it not saving. So let's just try 44 and 45. We're going to do 26. So 26 is solve the system by graphing. So this is lesson 44, number 26. Lesson 44, number 26. So the system is 2x minus y equals 5, 4x plus 3y equals 9. These are two linear equations, and where they intersect is the solution to the system. Now, we've learned different ways to do this. We can solve it by using elimination, or we could use substitution, and the third way is by graphing. This is the graphing way. It's the least accurate way, unless you're using a graphing calculator, and then you can do it pretty accurately. So we are going to solve both of these for y. So we're going to get negative y equals negative 2x plus 5. Divide everything by negative 1, and we have it in slope-intercept form. So it's going to be 2x minus 5. All right, that's the first one. The second one, we're going to get 3y equals negative 4x plus 9. Divide everything by 3. We get y equals negative 4/3 x plus 3. That's a 4. So we're going to graph these two lines, this one and this one. They're in slope-intercept form, so this last number is your b or your y-intercept. And your number in front of the x is your slope, which is your rise over run. So this isn't going to be accurate because I'm just drawing these hashtags on very randomly. So we're going to go up 5. We're going to go down to negative 5. That's our y-intercept. Our slope is 2 up 2 over 1. So I try to write these as evenly as I can, but they're still not going to be perfectly even. And if we get a fraction, it's going to be really hard to tell what it is. So I'm going to, my slope is rise 2, run 1. So I'm going to put a point right here. And then I'm going to connect them as best as I can. It's really hard on these kind of things. So you get the picture. It's kind of like that. So there we go. I'm just going to fill this in a little bit more so it looks like I made it through the point. Now this is going to make it even less accurate the way that I just did it. Okay, we're going to graph the second line. The y-intercept is 3. And we have to put the hashtags on here. Not the hashtags, the hash lines. 1, 2, 3. So we have a point at 3, and then we're going to go down 4. 1, 2, 3, 4, and over 1, 2, 3. And we're going to get something about there. And we will connect those with a line as well. And the place where they intersect is the solution to the system. What I'm looking for, if I had this on a test, was that you graph the lines accurately, and where they intersect was in the approximate place where the answer is. So we can see this is where it intersects. So I can't really tell what that is, obviously, right? Even if I zoom in, it's not going to be accurate, but we can kind of take a guess at it. If we zoomed in, it's going to look like it's almost at 3. So we could say 2 3/4, just for the fun of it, 2 3/4, so that would be 11/4. And down here, it's negative something where they intersect. I know this is totally wrong because I know what the answer is, but we're going to go with negative 3/2. Now, the correct answer to this problem is 12/5, which that one's not too bad, but it's negative 1/5. This is the correct answer. So what do? You're going to get an incorrect answer, so then you should solve it using substitution or elimination to get the correct answer. I'm not going to do that, but what I might do is take this one times 3, add them together, and we'll get our x coordinate, and then you substitute that in and get your y coordinate. All right, number 48, lesson 44, 28, is estimate a scientific notation problem. I did that in lesson 43, so if that's your problem, go back and watch the lesson 43 video. All right, onward to lesson 45. 45, we have C, 5, 11, and 15. So 45C is this one. It looks like x plus 1/7 squared equals 8. So we need to free the x. So if you had something like x squared equals 9, you would take the square root of both sides. You're always going to get two answers for these. You're going to get either 3, because 3 squared is 9, or you're going to get negative 3. So you're going to get two answers. The exponent of a 2 should let you know how many, lets you know how many solutions you're going to get. So don't forget your plus and minus when you do this. You're going to take the plus or minus of both sides. If you're doing Pythagorean theorem, you're only going to have the plus, because the Pythagorean theorem is a length of a side and it always is going to be positive. All right, whoops, I just erased the whole thing. Okay, let's try this again. X plus 1/7 squared equals 8. We're going to take the plus or minus square root of that 8 over there. And when you take the square root of a square, you just get what's underneath. So you get x plus 1/7 equals, plus or minus, I'm going to simplify the square root of 8. It's going to be 2 square root of 2, because this is going to be 4 times 2, right? Square root of 4 is 2, and it comes out. And then the last step is we have to get the x by itself. So we subtract the 1/7 from both sides, and we get negative 1/7 plus or minus 2 root 2. So that is problem C. Let's go to number 5, which is probably a distance problem, right? Okay, I did a distance problem in lesson 43, so I'm just going to set this one up. So it's lesson 45, number 5. So the train made the trip in 8 hours. The bus made all 80 miles of the trip in 12 hours. What was the rate of each, if the rate of the train was 30 miles greater than the rate of the bus? So the train made the whole trip. Whoops. So this is the distance of the train. Not enough friction here. And this is the distance of the bus. It made it all but 80 miles. So your equation is the same as the last problem that I did, very similar. Distance b plus 80, and then we're going to separate this out. Rate train time train equals rate bus time bus plus 8. Now we're going to find our parts. So the train, the time of the train is 8. The time of the bus is 12. And it said the rate of the train is the rate of the bus, rate of the train is the rate of the bus plus 30. So you're just going to substitute all those things in and then come up with the rates. All right, so we're on number 11, whipping through this lesson. Okay, our first trig problem, really, I was surprised no one asked this, any questions in the previous lessons. So this is lesson 45, number 11. You have a triangle. It looks like this. It's a right triangle. In order to do trig, at least for what we're going to do this year, it's always with right triangles. We're doing right triangle trigonometry, and we have sides 4, P, and 38 degrees. So we have the hypotenuse. The hypotenuse is the side opposite the right angle, and we have the side opposite the 38-degree angle, which is our angle. You could find this one and do trig from this angle, but we're just going to do it from the angle that we're at. So you would have your guy standing right here and looking, and that one's the opposite. This is hypotenuse. So we learned our SOHCAHTOA, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so we're trying to find P, which is the hypotenuse. So we need either this one or this one because it has the H in it. Standing at this angle, we have the one opposite. We don't have the one adjacent, so we're not going to use this one. So we're going to use the sine one. We remember that sine is opposite over hypotenuse. So we fill in the angle. The sine of 38 degrees is the opposite, which is 4 over P. Opposite over hypotenuse. Then we solve it. We get P times, we're going to cross multiply, sine of 38 degrees equals 4. Divide both sides by the sine of 38 degrees. We just simply place this in our calculator. We're going to round it to 2 places, so we're going to do the approximate symbol. So in our calculator, we're going to take 4 divided by sine of 38. And we get the answer of 6.497, so I'm going to round it to 6.5. And that makes a lot of sense. The hypotenuse should be the longest side in the triangle, so it better be bigger than 4, and it doesn't want to be extremely extremely bigger. So 6.5 seems like the appropriate length. Okay, last one in lesson 46, and it's number 15. Okay, it looks like, we already did one like this, but when I did this video before, I set this one up for you as well. So I'm going to set this up, and then I'm going to end this video and do a separate video for lesson 46. All right, because time is against me right now. So we have X, C, D, A, 4, 5. Now this one, we're going to separate it into 2 separate triangles. You're going to do the same thing. These kinds, you're just always going to separate them into 2 triangles. Sorry, this is kind of sloppy. I'm trying to hurry. All right, so these are your 2 separate right triangles. They're similar triangles because they have 2 congruent angles, so it means the third angles are congruent. Similar triangles have 3 congruent angles. So this is going to, your little triangle is going to be C, A, X, and the big triangle, it's going to be C plus D, 5, and you're going to add those 2 up. And this is not an A, it's an 8. So it's going to be 12 down here. All right, so this is an 8 too. I don't know where I got the A. Okay, so you're going to set up a ratio with these 2, so it's going to be 8 over 12. So 8 over 12, but I would reduce that and make it 2 over 3. And then to find your X, you're going to do X over 5. So you would find your X, which we're going to get 10, 3X. So we're going to get X is 10 thirds. I'm doing the problem here. So this X is going to end up being 10 thirds. And then you would do the Pythagorean theorem to get your C. And then you would do another ratio problem like we did in lesson 43. Okay, so that's it for lesson 45. I'm going to close this and see how far I can get in lesson 46.